Hello everybody, I will start my today's another live coding session. So in my today's practice, I will solve this question, +1. So in this question, I'm giving a large integer represented as an integer array digit, okay, where each digit I is the ith digit of the integer. The digits are ordered from the most significant to least significant in left to right order, okay, just like the natural number. I mean ordinary number. The large integer doesn't contain any leading zeros. Okay. Increments the large integer by 1 and returns the resulting array of digits. I see. So for example, if the original large number is like 123, the digit array should be an array of 1, 2, 3. And that's the input. So integer array is the input. And I will assume that the large integer from the digit array in this case was 123, and I will do +1. It becomes 124, and I will return the digit array, integer array of 1 to 4. Each element corresponds to each digit. So my output should be also an integer array. Okay, good. Yep. So now this question seems quite simple. And also the constraint is that the large integer doesn't contain any leading zeros. So it can be only 0, but it cannot be 0, 1 or 0, 2, 0, 1, 0. Let me quickly write it down because I think this is one of the edge case. Okay. Good. So that being said, my understanding on this question test statement is quite clear at this moment. So I will start thinking of this question with an example. So for example, if I'm given say 0, let me quickly write list every possible kind of possible input, including some edge cases I can come up first. I'm pretty sure this is one of the edge case I have to think of. So this means that if 1 is added and there is a carry up to 100. Yeah. Also, I can think in this way. So for example, this case, 59, there is one, carry up, but the number of digit doesn't change. But only if all the numbers are 9, maybe this, or this, or this. In this case, there is, one digit more. The returned array should be one element longer than the input array. So that's one case I have to consider especially. Yeah. But aside from that, yeah, even if there is a carry up like this from here, the number of digit doesn't change. Okay. Good. So I can say this is the case when no carry up. This is the case, there is carry up, but no. Yeah. And this is the case, then there is a carry up and one digit more. Okay. Yep. I just wanted to list the edge cases or patterns first because I don't want to forget the feeling. But yeah, let me come back to thinking of the solution. So I think the brute force approach for this question is that first we convert the digit array into the integer. Then I do +1, and then I revert it back to the digit list, and then I return it. So in that case, the time complexity should be O of n, assuming there's there are n digit in the original list. Yep. Because to converting the original integer array into the number, I have to do, in the case of 1, 2, 3, I will do 3 plus 10 times 2 plus 10 to the power of 2 times 1, blah, blah, blah. Yep. Then +1, it takes only the constant time, and then converting it back to the integer list, it takes O of n time. Yeah. Yeah. Because from 122, I divided by 10 and against the modulo 3, which should be the last digit in the returned array. And in that way. So I think this is probably good enough because, you know, I cannot achieve the time complexity faster than this because at least I have to check all the digits in the list, given list. This is the best achievable time complexity, I'm pretty sure. Yep. But that being said, for the implementation simplicity, I prefer another solution. Yeah. So I'm inclined to use these patterns. So what I mean to say is, firstly, I will check if all the digit are 9. In that case, I will create the completely new array and return it. Oh, by the way, what I'd like to confirm first as the interface is it okay that I mutate the given list? Yeah, I will assume it okay. Yeah, assuming that's that, only for this case, all the numbers of the digit 9, I will create a completely new array and return it. But for other cases, I will use the given list. Yep. So I will do the carry up from the least digit to the largest digit one by one. So for example, in this case, like 699, I will increment the least digit 9 to 10, then carry up 1 to the 9. Yep. And then 9 plus 1 is 10. So I have to do the carry up again. And the carry up should be, applied to 6. And 6 becomes 7. So I get 700. And this applies to the pattern number 1, no carry up. Because theoretically, I just have to increment the least digit and that's it. There's no carry up. So I can think of the 9999 case as the kind of edge case. Okay, so that being said, let me start implementation. Oh, by the way, this takes also the overwhelm time because firstly I will take a look of the digit in the given list to check if all of them are 9. And if it's true, I will initiate the new array. And checking and creating a new array both of takes O of n time. But accurately saying, it takes n plus 1. Yeah. Aside from that, I mean, if not the case, I will do the carry up. I mean, I increment the least digit. It takes constant time, and I will keep doing the carry up. In the worst case, I have to do the carry up until the most significant digit. So in that case, it takes over time. Anyway, in total, the worst time complexity is over n. And for space complexity, I don't need any extra space because I yeah. In the first case, 999H case, I will create a new array, but it's the returned array. So it's not the extra space. And for other cases, I will just mutate the given array, so it doesn't take any space, extra space, which is non-constant. So the extra space complexity should be O of 1, constant. Okay, so that being said, I will start my implementation. Let me do it this way. Okay. So far, I've implemented the edge case 999. I will implement the is09 method later. Otherwise, I will mutate the digit array. So I will traverse index -1. I mean, this is index -1, and this is index -n. I will traverse from index -1 to -n. Then what I should do is if wait, so okay, so this is how I guess the carry up, and also this is how I guess the digit I. Yeah, but also I have to take care that I have to initiate carry up with 0, and I have to increment the digit I with the carry up first. Okay, so what I'm saying is firstly, in line 32, this becomes 10. Then carry up is now 0. And in line 35, I wait. Okay, this is good. Carry up is 0, so now digit I is still 10. Then I get carry up 1, and digit I is updated with 0. Yeah. Then here is the second step in the traversal. Digit index second to last. Yeah. This is incremented by the carry up 1. Then from here, carry up should be calculated and digit I should be calculated. Okay. Good. And 1. Oh, and in the end, I will return digit. Okay. Just in case, I confirm that carry up here is 0. Okay. And this works basically. But one optimization I can make is that in line 35, if carry up is 0, I can break because I don't have to update the array anymore. Oh no, it doesn't work because in line 33, I initiated with carry up 0. Hmm. So this is a bit of technique, maybe just too dedicated to the optimization. But I will do this. Yeah, I initiate the carry up with +1, and this in this way, I can do this. If carry up is 0, I can break. Okay, so this is my implementation. So looks good to me. So let me walk through my code. Always every single 2 cases, 99 and those 49. Okay, or maybe 119, 129. Okay, but what I forgot to do is implementing the 809 digit implementation. This is quite simple. Yeah, this works in this way. Okay, so for 99 case, I expect that this returns 100, and I will check if this is true. Okay, so if 99, firstly in line 28, 9 is n is initiated with 2. Then in line 29, I get false. I skip walking through is an 09 method. I believe this is correct. So for the to save my time, I just skip. And so in line 30, I return 1 plus 0 times 2, which is 100. Okay, so this is correct. Good. And for 129 case, I expected this returns 130. Okay. So here, n is 3. And because this is not all 9, I go to line 39. And carry up is now 1. Okay. And let me see. So in line 41, I start with -1 to n is now 3, so -4. But because in Python, this is exclusive, so I will check in this way. Okay, and I start with -1. So firstly, carry up is not 0, so I go to line 44, and digit I, -1, this is incremented to 10. Yep. Then in line 45, carry up is now 1. And for digit, this becomes 0. Okay. Then I go back to line 41, and now I is -2, and carry up is now 1. So I go to line 44, and digit I, 2 is incremented, and now it becomes 3. And carry up is now 0, and digit I is 3. Okay. So this becomes 0. No update on the digit array. I come back to line 41 and then 42. Because carry up is not 0, I break. And then line 48, yes, carry up is not 0, so I return digit, which is 130. Okay, this is completely expected. So this was a part. Okay, I'm pretty confident in my code, aside from its no9 method. But let me look at it again. This seems to be correct. So I execute my code. Oh, sorry. Sorry here. Good. I submit my code. Okay, accepted. Great. So in this video, I solved the question +1. And in this question, I'm giving an integer array digit, and I will assume that that's a big integer, and I increment it by 1, and then I get the result. And what I will return is the digit array, which represents that incremented number. Yep. And in my solution, I basically, think of the, I firstly increment the I increment the least significant digit first, and then I think of the carry up. Yep. So in that way, the given digit array is mutated, and I get the incremented digit array. But just one edge case was that all the digits in the given array is 9. In that case, I have to return, say, 1, 0, 0, 0, blah, blah, blah. So I treated it as the edge case and returned 1 plus 0 times n kind of array. Okay, so that's pretty much it. I finished my today's coding practice with this. Thank you so much. Bye.